Okay, now we're going to look at a different derivative. And this is the derivative of the exponential function with e as its base. E, of course, is Euler's number. How do you spell Euler? Like this. Euler's number. And that is e, the base e that we're looking at. So we're going to take a look at problem number 2 here. But first, let's take a look at some examples. So what I need you to understand is that whenever you take the derivative, and I'm going to rewrite basically the definition, whenever you take the derivative of some exponential function e to the u, you get e to the u itself, but then you multiply by the derivative of whatever the exponent was. So this is where the chain rule comes into play. All right, so this is a special case of the chain rule. All right. So if you were to suppose take the derivative of something like e to the x, well, its derivative is just itself e to the x, but then you multiply by the derivative of the exponent, but the derivative of x is just 1, so you end up with e to the x. So e to the x, its derivative is e to the x itself. But it's a little bit different when you take a look at an example that looks like this. Suppose e to the 2x. So you're going to get e to the 2x times the derivative of 2x, which is just 2. So you end up with something like 2e to the 2x as the derivative. All right, let's take a look at another example. All right, we're going to take a look at a couple of examples before we actually get to the problem in question. So what about this one? Well, you copy and paste. That's what I always say, copy and paste. Then you multiply by the derivative of this exponent, which the derivative of x squared is just 2x. So you end up with 2x e to the x squared. All right, just like that. How about one more for good measure? D dx, and how about I take e to the negative x? Okay, this one's nice. E to the minus x times the derivative of this negative x, which is just negative 1. So you end up with negative e to the negative x. Something looks like that. Now this next one, the problem we're actually going to look at here, y equals e to the 9x over 2. Now this one looks a little bit confusing, but it's actually not that bad. What you need to understand is if you could rethink the way that it looks, you know, maybe write it as 9 over 2x like this. This is just linear, a linear exponent, if you will. It's like if you have the equation of a line, what's the slope? That's what I'm getting at. So to find y prime, you're going to write it again, e to the 9x over 2 times the derivative of this exponent, which is 9 over 2. All right? And so you end up with something that looks like this. Okay? 9 over 2 e to the 9x over 2. Something like that. All right? So there's the derivative for this problem. So again, this taking the derivatives of an exponential base is the chain rule. All right? It's just implied there. It's the chain rule. So hopefully you found this really easy. Hopefully you liked it. And remember, as always, like and subscribe.